Hello everyone, and welcome. Have you ever wondered how scientists can take a complex mixture, like fruit juice, and precisely measure the amount of each different acid inside? One of the powerful techniques they use is called ion exclusion chromatography, and today we're going to break down exactly how it works. At its heart, ion exclusion chromatography, or IEC, is a separation technique where the name itself gives you the biggest clue. Its primary job is to exclude ions. Imagine a long, thin tube called a column, which is packed tightly with tiny, porous beads. These beads, which we call the stationary phase, are the key to the whole process. They are made of a special resin that has a fixed electrical charge. For our example, let's say all the beads are covered in fixed negative charges. Now, we inject our sample, which is a mix of different molecules, into a liquid called the mobile phase and pump it through this column. Here's where the magic happens. Any molecules in our sample that are strong, fully negative ions, like chloride, will be strongly repelled by the negative charges on the beads. This electrostatic repulsion acts like a force field, preventing these ions from entering the tiny pores of the beads. They are forced to stay in the liquid flowing between the beads, taking the fastest possible route through the column. Because they are excluded from the pores, they exit the column first. But what about neutral molecules, like a sugar or an alcohol? They have no charge, so they aren't repelled by the beads at all. They can freely wander into the pores and back out again. This means their path through the column is much longer and more complicated. They explore both the space between the beads and the space inside the beads, so they take much longer to travel through an elute from the column much later. The real power of IEC comes when we analyze weak acids, like the citric or malic acid found in food. These molecules can exist in two forms, a charged negative ion or a neutral, uncharged molecule. The form they take depends on the acidity, or pH, of the mobile phase. By carefully controlling the pH, we can influence this balance. The neutral form can enter the pores, which slows it down, while the charged form gets excluded and moves quickly. This difference in interaction allows us to separate different weak acids from each other. So, the separation order is predictable. Strongly charged ions that are repelled come out first, followed by the weakly ionized acids, and finally, the truly neutral molecules come out last. This makes ion exclusion chromatography an incredibly useful tool for analyzing things like organic acids in wine, fermentation products, and beverages. Thanks so much for watching. If this explanation helped you understand ion exclusion chromatography, please give this video a thumbs up and consider subscribing for more science explained simply. Your support truly helps the channel grow and allows us to make more videos like this one. See you next time.